summing up, the implications for assessment that when designing, when using assessments, different types of assessments, it's important to look at the tasks and think about universal context. How are the specific context for it's also important to think about measuring both concepts and skills, and both informal and formal. They're both very important assessment. And there's a lot more information on this on the paper that will be posted in a growth. And I think I just wanted to talk about different kinds of numeracy outcomes. So we looked at a lot of different assessments and different frameworks that are already out there and again, this is much more detailed in the paper, but TIMS and the TIMS numeracy. We looked at Reedman's, we looked at the UNESCO Brookings learning metrics, and EGMA, TIMA, author Nuevo, which Jeff is now more in detail about. And I'll turn it over to
Okay, Yasmin, thanks again. Go ahead and slide. So for the last 3 questions, the GIZ asked us to answer or at least respond to. The next one with current assessment practices. And what we did here was to use the classification that was developed by 2 consultants, Vincent Green and Callahan, that many of you are familiar that 4 different kinds of assessment: public examinations, national assessments, international, include the regional assessment, and then classroom-based assessments, which some people formative or continuous assessment. And then we took the 5th one, which is assessments. Go ahead and move forward. Show some examples of different assessments. Next slide. So the 5 that we'll look over here real quickly are, the early grades mathematics, teams of early mathematics, the annual status of education report, ISO, capability, and TIMS numeracy 2015. Next slide. An example from on EGMA, and I believe this was done in Mali. With this particular, and usually there are about 10 different activities or components, or 8 or so on EGMA. This one has to do with comparing quantities. So the first one, the child needs to compare 6, 8, and this is actually administrator's answers there. The child doesn't see, but the idea is that they do 10 of these. If they can compare quantities of different sizes. Okay, next slide. And here's a similar on TIMA, and on this one, there's a number up top on each set of 3. So for instance, with the practice one, the idea is to look at the number 6, and then for the child, one is close or 9. So it's an informal skill with a mental number line. And on TIMA, there are items now, and this is one of them. Next slide. Complete OSCER, and this one has on the first part needs to name 1 through 9. Second one, similar exercise with 2-digit numbers. There's subtraction, and then there's division. So this is a kind of test that can be done in say 5 to 10 minutes with a child. And this one has been administered mostly in India, but also in Pakistan. Next slide. Oops. And this is from UASO, which is being administered in 3 countries in East Africa right now. And it's a little bit more extensive than OSCER, but same group has been working on these and a similar idea. So again, this is the entire test. So number recognition, addition, subtraction, multiplication, and then some problems with currency, with shillings. And this is an example from Tanzania. Next one. And this is a new test. We just got details of this one during the conference from the folks at IEA. So TIMS is planning on doing a numeracy assessment in 2015. It's geared at a lower level than the 4th grade TIMS. And in fact, the results from 2011, as many of you know, just came out yesterday. So, please look at the IEA website for some interesting findings there. This one is working with whole numbers, fractions, geometric shapes and measures, and data display. The fractions is a different section than what's on the regular TIMS. And on this one, children can take it up to grade 4, but really the content is geared towards around grade 2 in a developed country. Next slide. We focus quite a bit in the paper on need for development of new tools, because with the existing tools, they seem like they're doing a good job of covering content, and many of them are widely used out in the world now. But the biggest area of need that we see right now is in the area of classroom-based assessment. And many researchers believe that this has the most potential for improving learning outcomes in literacy and numeracy. As many of you know, it's integrated into daily teaching. You can use a variety of techniques ranging from observation to quizzes. And in many places, it's not done particularly well, but, again, just has tremendous potential. One of the reasons that it's not done well, I think, is because it does require so much teacher training and materials. Okay, next slide. And real quickly, in Honduras was a place where I worked for about 3 years, and they have a good program going on there that's been in place since 2004. And they implement the entire curriculum in a comprehensive way, ranging from textbooks to diagnostic testing to formative assessments, end-of-year assessments, and performance levels. So, to me, this is a model that could be implemented in other countries in a comprehensive way, and it's working quite well in Honduras, and we've seen some good gains in student learning there. Next slide. Here's just a quick example from Honduras of a formative assessment, and this is just one page of it. There are about 20 questions that the child needs to do in numeracy at the end of each month. So there are 8 or 9 assessments during the school year, and then they're scored. Children's scores are put into performance categories as well. So it's used for diagnostic purposes, but then also, the teacher records the results, and they can share those with parents and use them for report cards as well. Next slide, please. Now, here's an interesting finding that we presented in the paper as well that many of you know about. And in fact, Shireen from Save the Children posted this one on the website for our community. And this is kind of a surprising finding to many people. Don't get too baffled by the statistics here or anything, but the idea is to use a school entry measure to predict later achievement. So they had 4 different school entry measures, and they wanted to know the effect of those measures on later achievement, say at the end of elementary school or primary school. And this was done with very large databases in Canada, the US, and the UK. So, as you can see in the cell where it says reading 0.24, early reading is a good predictor of later reading, as we might expect. In the cell where we see 0.42, math is even a stronger predictor. Early math is a stronger predictor of later math. The surprising part really is that if we look at math as a predictor of reading, it's actually a stronger predictor of later reading than early reading is. And if we look at a combined reading and math score, which is at the last column, math predicts this combined score about twice as well as reading does. So, something is happening here with early math and, children's concepts and skills that's allowing them to do better on both reading and math. And then the next slide. One other comment by the researchers, again, this was done by about a dozen researchers in 3 countries, a very, very large study in 2007 you can read about, is that they're very impressed with testing young children and getting results that are highly reliable measures of their early skills. And the last slide. Just wanted to say thank you to all of you. Please feel free to write us for more information. And again, the presentation's on the web. Our paper will be ready in about a week, and the GIZ will be publishing those papers. It's been a pleasure working on this, and thanks so much. We'll be ready for questions when they come along. So thank you.
Thank you so much, Jeff and Yasmin, for the presentation. That was really nice. I just wanted to remind everyone that I'm recording questions, and at the end of the session, I will convey them to Jeff and Yasmin, and they can answer it for you. So if you have any questions as the presentations are happening, please do type them into the chat box, and then I will record them, or I will convey them to Jeff and Yasmin. So thank you again, Jeff and Yasmin. We will go to the next presentation now. The next 2 experts that were invited to the conference will talk about mobile learning, particularly for numeracy. So Carmen and Sarah, whenever you guys are ready, you can start.
Sarah is starting. Can everybody hear me? This is Carmen.
Hello?
Right. Okay.
Hi. Turned on here. Hello? Okay, I'll go ahead and start, assuming everyone can hear. I'm Laura, and with RTI International, and we were by GIZ to do the study mobile learning and new. So our questions were around what are the benefits and challenging mobile learning into early grade education. What is the role of a teacher with learning? And specifically, how can the community and contribute, and also be the effect of mobile learning on teachers and parents, numeracy as well, and even how can mobile technology measure and assess numeracy gains. So, of course, in the context of early grade learning, early grade. And Yasmin have already talked a lot about, what are specific numeracy skills. You can go on to and so I won't spend a lot of time, but just to say that our study really does cover a broad spectrum of both traditional mathematics and numeracy, which can be defined as sort of the science of math in the real world. So, you apply the addition and subtractions and all these processes to the real world, and need to make sense of mathematics. So, understanding numbers, the number system, doing calculations, process, recognizing, and are not so computational, solving, decision making, logical reasoning, and skills. So our task was to really see what's happening today around the world with mobile learning and early grade mathematics, and try to draw some lessons and challenge forward. Okay, next slide, please. So with that said, then what is mobile learning? And I think it's important to, aside from mathematics, it's also important to just talk about learning in a broad sense. A lot going on in other domains, in literacy, in health education, in higher education, and call themselves mobile learning. But, what do we really mean by this? And so I built this, which I will try to talk you through, to really show how much a variety of what is learning. On the one hand, so horizontal spectrum, you have mobile learning, and you have stationary mobile learning. If you have a mobile device, whether it's a phone or a computer or a laptop or a tablet, you can either be using that device to learn while you're out and about walking around in your community, or you can actually be somewhat stationary, sitting at your desk and things that are to you by your mobile device. And then your formal and informal text, so the up and down axis. A lot of mobile learning actually in classrooms, and a lot of it is formal settings. So just people taking on their through mobile.
smartphone, tablet, we found a lot, especially in the United States and in the UK, but there are a couple of initiatives going on that use more smartphone and tablet devices also in some other regions of the world. Impira is in Mexico. It's an initiative that leverages the visualization features of the smartphones. There's a lot of graphing activity going on. Innovations for Learning, are also known as TeacherMate. It's basically a differentiated instruction system that is delivered previously on custom-made TeacherMate devices, but now also on iOS devices. And it basically contains different curricula and allows teachers to assign activities for students to do. Typically, it's kind of app-like activities for teachers to do depending on where they are in their learning. In sort of the assessment side of things, you probably know about Wireless Generations work for DIBELS and M-Class Math, but we are developing a tool called Tangerine Class, an open source tool for curriculum-based measurement, what Jeff was referring to, the more classroom-based assessment that is for early mathematics and early reading. Next slide, please. So there are a bunch of initiatives already going on, and if you go back to the quadrant graph that Sarah showed you earlier, this slide here just gives you a very quick one-glance view as to where some of these examples fall within this framework of stationary versus mobile, formal versus informal, and the type of individual versus collaborative domains that mobile learning initiatives can maybe sort of structured within. Next, please. Yes, and of course, Mira, I'm just seeing your comment. I mean, these were just a few of the initiatives. There's a whole lot more out there. And one thing that Sarah and I would really love to get in terms of your feedback, actually, and Deepa, if I may make you the sort of collector of this, we still have a week to finalize the study, and we would love to hear about any that we may have missed. So if you know of initiatives that are going on that fall into this framework of mobile learning and early numeracy specifically, please send them directly to Sarah or me, or maybe Deepa if you'd be so kind, so that we can make sure to include them in the report. Going to the last slides, putting theory into practice was then the next step for our study, and also the real work of the conference in December. Here we discussed what are some of the cross-cutting issues or contextual factors and challenges for mobile learning. Obviously, charging the devices is one, much less of a challenge devices than it is with the more power-heavy, power-consuming PCs and desktop environments. Network coverage clearly is another one, both for just SMS as well as for 3G type data transfer. Costs, yes, you can pick up probably one of these basic phones at $25 a piece, but then there's costs of the SMS or of the data connection that need to be considered. Language and script is a big one. Deepa is in Cambodia right now. The Cambodians have obvious challenges with the Khmer script. Although content may be developed in Khmer script, the actual phone and the UI for the phones will be not in their script. So there are struggles and challenges with that. And then there's this whole the age of the children. Our study was supposed to ages 4 through 10. That brings with itself issues about, for example, devices directly to children, their security concerns, their privacy concerns, depending on how connected the devices are and what data children that need to be, and here content, quality of the applications and quality of content, as well as policies. Next slide. Recommendations, the working group in Berlin also came up then on the basis of presenting some things to them, and through many hours of discussion, a couple of recommendations that we will be including in the report. Number one, we need to take care that the information and the ad going out on mobile learning is balanced. Certainly opportunities to mobile learning, we have outlined some of them, but there are also, so balanced advocacy is something that I think we all need to take ourselves into the responsibility for, and that includes demystifying and rationalizing where mobile learning really makes sense. And much of this is related to, are we doing a mobile learning initiative because we can, meaning because there's access, or are we doing it for if there are more rigorously or credibly evaluated initiatives, we need to find some place to centrally host those so that they are more widely shared and easily accessible, sort of a what works clearinghouse. And then a deep concern was about research. Clearly there's a lack of rigorous evidence in this field, as this is an emerging and very young field. And before, we felt before everybody goes out and does random pilot projects, we may try to sort of, put our heads together and develop some sort of theory of change, and really some sort of like a framework, an indicator framework for mobile learning, along which then research can be plotted or mapped, and maybe new initiatives could be mapped against, so that we get a more sort of systematic picture on the affordances and the challenges related to mobile learning for early numeracy. And last but not least, a key recommendation clearly also needs to be promoting an enabling environment where mobile learning makes sense. There may be restrictions in regard to policies or opportunities, content, ideally being open source and freely available given the context we work in, interoperability, as well as business models around M-learning, because clearly, as soon as this involves data transfer of any kind, it involves the telecoms and other actors. And so there's need here to look at this also from a partnership lens in terms of the opportunities provided and potential barriers to the taken into account at stages. And I will stop here, and hopefully we still have time for some questions. I've seen them all triggering in, but I'll hand it over back to Deepa. Thank you.
Thank you so much, Carmen and Sarah. That was very, very interesting, and you got many, many questions. We'll only be able to address a few. I see that Sarah has actually answered quite a few of them, but we'll answer a couple. I'll let you answer as well, or talk about some of them, and then the rest put on the community practice site, and they'll be answered in detail. But let's start with Jeff and Yasmin's presentation. They had 2 questions, and Jeff and Yasmin, if you can go ahead and address them. The first question was from Frances, and she wanted to know, do you hope that classroom-based testing can focus on the larger concepts or more on the specific skills learned? Mira, and she wanted to know about the data that was generated assessments, where it is available for public.
Okay, I think, can everyone hear me? The first question, which was from Francis of classroom-based testing concepts or skills. Just really I think one of the beauties of base assessment is that you can post because you have a lot of data points. So you can observations, you can use quizzes, use more formal tests. You can use a lot of different types of methods to look at both skills. So it gives you a really good measure of both. So I think, ideally we would want classroom-based to try and get different data sources, get all these different ways, and to measure all of them all together at the same time. And that's, I think that's one of the things you can do with classroom-based assessment is look at both. And I hope that answers your question. I'm not sure if that's exactly right, but that's what I understood to be the question. And I think Jeff was going to the next question.
Jeff, do we have you? No? Maybe Yasmin, do you want to go ahead and answer the second question?
Okay.
Jeff, we can hear you now. Please go ahead.
So on the assessments and data are available. EGMA has good documentation on the web through the EdData website. There are some of the more recent assessments that are still waiting for approval in terms of publishing results, but those should be ready soon. And Wendy Relangita from RTI can give more information to anybody who's interested on that. With TEMA, the Test of Early Mathematics Abilities, they have an extensive user manual that publishes norms and grade level equivalents, even a math IQ. So there are quite a few results from TEMA on the web. For my own dissertation, I did a comparative study using TEMA of African, US, and Korean children, young children, on how they learn math, how much math they're learning, the rates at which they're learning math. So I could send a reference on that to anybody who's interested. OSSER's results are on the web as well. They do a good job of publishing them. Same with UASO. And with TIMS, as I mentioned, the 2011 results are out as of yesterday. One of the people who was in our group, Hans Wejemaker, who's the head of IEA, has a nice video on the web to help explain the results, so that's good timing for that. With the TIMS numeracy, it won't be administered until 2015, but the target on that happens to be countries that are the same target for the GIZ in these papers. So, in 3 or so years, when that is done, I think the results will be quite interesting for us as well. And I'm sure there are many other assessments out there, as Carmen mentioned. We had to make a selection for this paper, but if anybody wants to send us results or has a particular assessment that they think should be included in the paper, please let us know.
Okay. Thank you so much, Jeff and Yasmin, for answering the questions. Francis actually has a follow-up question, and Francis will address your question on the community of practice site so that we can also let Carmen and Sarah questions. Carmen and Sarah, I think, Sarah, you've answered quite a few questions on chat box, but you could speak a little bit about how remote communities can use mobile technology, and also a little bit about the
Sure, yeah, and I hope I was able to do justice to some of these questions, answering them quickly. Yeah, I think remote communities, again, the statistics are out there that many people, even communities, have now actual phones, even the very simple mobile phones, like the Nokia, more sophisticated feature phones, access to, PRS or 3G data connectivity, and they're really dependent on the for their daily lives, especially in cities. I mean, these are the people who depend on their phones the most. Farmers getting market prices, for example, nurses getting advice. Sorry, I'll turn on my camera. Nurses getting advice about treatments or diet. So again, that's one of the real drivers, I think, why we're learning at all. So many, we can access so many people that have been hard to reach in the past. Of course, there's going to be gaps. There's still gaps in, for example, leadership. And of course, we're talking about this study grade learn mathematics. And certainly the people are not first graders, it's their parents. So there's a question about, are parents willing to share phones with their math activities at home? We just don't know that yet. There hasn't been enough out there. In countries we have it's quite common to distract their kids' phones or to let, but we just don't know if that's the case or if parents would feel comfortable with it. Imagine anyway, simple text-based phone, and SMS messaging, you can send calculations, math questions, math quizzes. All of this can be done through programmable databases that communicate through SMS protocols. You can also just use even the number keypad on your phone to help kids learn to recognize numbers. And there's calculators within the phone. So I think a lot of people, when they think about mobile learning, are often not thinking about even these very simple features of phones that actually do lend themselves to math learning, math teaching and learning, where in places where there may not be textbooks, there may not be other forms of learning. But we certainly are not saying that this is the solution for everyone everywhere, and I want that to be really clear. This is one approach among many for teaching and learning mathematics. When one thing isn't available somewhere, you look for another approach. So we do want to be clear that this isn't a one-size-fits-all approach for everyone everywhere. It's really something that has to be very context specific. Again, if you think about that grid, what are your objectives? Are you trying to get what you can get out of a computer-based learning, drill and practice exercises, but you can't afford a computer? Well, then put the drill and practice on your phone. Or are you trying to change pedagogy? Are you trying to change classrooms where you don't want teachers standing up delivering lectures? You want kids learning about math outside in their environments. I don't think we didn't have an image of it, but there's a great program where you can overlay a virtual protractor by using your camera phone, so you can actually go out and measure angles of the windows in your house or the roof of your house. And this is really making math linked to reality. So anyway, I'm digressing, but on the Senegal program, this is actually Nokia, the MoMaths is one of the most well-known math examples of mobile math, but it's more at the high school level. It's been more directed to middle school and high school math content learning, and it's basically Pearson education content that has been digitized for delivery through a mobile phone. Again, it's a kind of a web-based database where you can access questions, word problems, quizzes. You send your responses. There's rankings. There's a variety of social media, and this has usually been used for middle students to practice and prepare for exams. They've just adapted this now for Senegal. I think with similar content, although there's not a lot of information out there at present, whether they've changed the content or not, but I think it's basically aimed to improve teachers' own content knowledge of math, because in Senegal, many teachers don't have even a 6th grade education, so their math skills might be an 8th grader in South Africa on that, because again, I don't know, the information isn't out there at present on what the specific content of this program is. I'm just going on the assumption that they've just adopted this content now for teachers in Senegal. I don't know if they're talking about teaching pedagogies or math teaching strategies in addition to content, but that's something we need to try to get more information about from Nokia, and UNESCO are the people doing this. Okay, I'll stop there in case there's other questions, or maybe Carmen, you want to add something to any of the answers that I gave already?
Carmen, do you have anything to add really quickly, maybe in 2 minutes, and then I'm going to close the webinar. Okay, great. Thanks, Carmen. And I wanted to thank everybody for joining us today, and I apologize again for the technical issues that we were having at the beginning, but I'm happy that everyone was able to sign in later on and join the webinar. And I also wanted to thank our experts today, Jeff and Yasmin, for their presentation on the learning outcomes and assessments, as well as Sarah and Carmen on the mobile technology presentation, specifically for numeracy. And what I'm going